Okay, so to continue our discussion of chemical reactions and chemical equations, first thing we have to talk about are the parts of a chemical equation. Now, you have definitely seen chemical equations before in previous classes and even in in the TV and movies and stuff like that. Maybe didn't know what every bit of it meant. So we're going to talk about a few of the main parts. On the left side, the ingredients, the thing that go into the reaction, in this case CH4 plus O2, these are going to be labeled reactants. These are your ingredients. These are what goes into the reaction. And on the right side, what we're making from the reaction, those are called products. And then if you look at the physical states here, in this case, they're all labeled G. That means that the particular physical state for all four of these substances is gas. So you have G, which is gas, you have L, which is liquid, you have S, which is solid, and you'll also see AQ, which means aqueous, which means dissolved. So like salt water would be aqueous NaCl. Okay, and then down here it says an important side note, just to kind of point out here, elements are sometimes in pairs, like O2. That's called diatomic. So it means that when you have oxygen being used in this reaction, even though it's a pure element, it's not a compound, it does have a subscript, and that subscript is going to be 2. Now there's also hydrogen, nitrogen, fluorine, chlorine, bromine, and iodine that all act the same way. Okay, so another thing that we do sometimes is we turn word equations into chemical equations. So let's talk about doing one of these here. It says zinc reacts with hydrochloric acid. So that means on the reactant side, we're going to have zinc. Hydrochloric acid, you don't really know this, but its formula is HCl. And it's going to produce zinc chloride. And if you remember from last semester, zinc is +2 and chloride is -1. So I'm actually going to need 2 chlorides, so ZnCl2. And hydrogen gas, if you remember back to the previous slide, or actually up above on your notes there, hydrogen is one of those diatomic elements. So that would be turning a word equation into a chemical equation. And then lead 2 nitrate, so lead with a 2+ charge. Nitrate, if you remember again from last semester, has a -1 charge. So I'm going to need 2 nitrates to balance the charge of the lead. It's going to react with potassium iodide, so Ki, and it's going to produce solid lead 2 iodide, so PbI2 solid. Notice there was nothing said about the physical states of my 2 reactants, but it did mention that this was solid. And it's also going to produce aqueous potassium nitrate, so KNO3. Again, a 1-to-1 ratio this time because potassium is +1, nitrate's -1, and aqueous means AQ. So that would be 2 examples of turning word equations into chemical equations. You probably need your list of polyatomic ions that you learned last semester to help you out with some of those problems, and we'll do some more in class for sure. All right. So then, we can talk about balancing equations. So when you see in a balanced equation this big number out in front of something, that is the coefficient. That's telling you that you have 3 of this whole thing. All right, so in other words, we have 3 magnesium phosphate formula units. And so what does that mean about magnesium ions? Well, if I have 3 of this entire thing, so like if you can just imagine parentheses around the whole thing, and in each 1 unit of magnesium phosphate I have 3 magnesiums, I would just multiply my subscript 3 by my coefficient 3, and that would tell me that I have 9 magnesium ions. Then as far as phosphorus atoms go, well, this 2 out here on the outside of the parentheses means that I have 2 phosphates. And so that means that I have 2 phosphorus atoms. But again, we have to multiply that by the coefficient out in front. So we have 6 phosphorus atoms. Now, oxygen we really have a lot of because we have 4 times 2 with the subscripts, which is 8, times 3 from the coefficient. 8 times 3 is 24 oxygen atoms. So take a look at those numbers, 9 magnesiums, 6 phosphorus, and 24 oxygens, and just see if you can figure out, if you fully understand where those numbers came from. And if you don't, just rewind and give it another listen and another watch. Okay, and it says an equation has to be balanced. So this is not an equation, this is just a single formula. But when we do write a chemical equation, like we saw in the previous slide, it has to be balanced to satisfy the law of conservation of mass, which just means that when you do a reaction, if you burn a piece of wood, you get the same mass as a product of the reaction as what you put in as ingredients. So you can't have atoms disappear, which means you can't have mass disappear. All right, so just as a little exercise, let's see if we can figure out how much of everything we have down below here. So if I have a coefficient of 2 out in front of H2O, that's going to multiply by 2 to give me how many hydrogens? Right? So we're going to have 4 H's. And then how many oxygens would I have there if there is no subscript on the oxygen, but I have a 2 out in front? Right? So we have 2. Okay, how about this next one? So MnClO4 3. So manganese, we just have 1 of, because that 3 out there in the parentheses does not go, it only goes for what it directly follows, which would be what's inside of the parentheses. So we just have 1 manganese. We do have 3 chlorines, because of the 3 times 1 there. And then if you do 4 times 3, or 3 times 4, we get the number of oxygens. So we get 12 oxygens. And then finally with this last one, my calciums, again, multiply subscript by coefficient. 3 times 3 is 9. And do the same thing for nitrogen. So 2 times 3 would be 6. So 9 calciums and 6 nitrogens. So let's talk about the rules for balancing equations. All right. These rules are written down. I only want to add one thing, and then we're going to use these rules to do a little bit of practice, I think is the best way to discuss these rules. All right, so it says only change coefficients when you're balancing an equation. And you'll see an example of balancing an equation in just a minute. But we never change the subscripts. So here's what I mean. If I have a reaction like H2 plus O2 yields H2O, first thing I notice here is I've got 2 oxygens on the left and only 1 oxygen on the right. So you might be tempted to throw a 2 on this oxygen as a subscript, but we can't do that because once we've written the equation, we cannot change that water molecule into something new, which is what we would be doing by putting a subscript of 2 there. So instead, the only way that I can get myself to have 2 oxygens on the right is to put a coefficient of 2 out in front. Now you might have noticed that would also give me 2 times 2 is 4 hydrogens. So then what would I multiply my 2 by on the left to also have 4 hydrogens? Right, so I would put a 2 there. Okay, so never change subscripts. Once you've written your formulas, those have to stay the same. They don't change. Only change the coefficients, which are these big numbers out in front when we're balancing. These tips we'll come back to here as we do some examples. Okay. Oops. All right, let's take a look at some examples here. So the first one, Na plus Cl2 yields NaCl. So what's not balanced right now would be the chlorines, because on the right we have 1, on the left we have 2. So again, we can't put a subscript 2 on NaCl, or I'm sorry, on the Cl in NaCl, because NaCl2 is not a compound. It doesn't balance the charge of sodium and chloride. We cannot change the subscripts, but what we can do is put a 2 out in front and say that we have 2 sodium chlorides. Now the other effect of that is that it gives us 2 sodiums, which means to balance the sodium on the left, we simply have to put a 2 there. Okay. This next equation we actually just did, but we'll go through it anyway. Oxygen's not balanced, so to balance oxygen I need a 2 out in front of water. That gives me 4 hydrogens on the right, so I need 2 out in front of H2 on the left. And then the next one, we'll do one more, and then we'll do the others in class. Fe2O3 plus CO yields Fe plus CO2. So this one's a little tougher, but let's try and see if we can get it figured out here. If we've got, let's say, iron, right now we have 2 on the left, and we have 1 on the right. So maybe I put a 2 out in front of Fe on the right. That balances iron. Then, as far as oxygen goes, I got 4 on the left and 2 on the right. Now, what I could try to do is put a 2 in front of is put a 2 out in front of the CO2. The problem with that is, though, that's going to imbalance my carbon. So now I got to put a 2 there, and now at this point I would have 5 oxygens on the left, because I have 3 here plus 2 there, and I have 4 on the right. So that one's getting kind of tricky. So maybe we'll try this one over. Let me write it off to the side here. So Fe2O3 plus CO yields Fe plus CO2, and the physical states don't really matter for balancing, as far as balancing is concerned. Let's think about maybe what we could do. We want to get our oxygens on the left, in this case, to an even number, okay? Because on the right, I'm always going to have an even number because I have CO2 there. All right. So instead of maybe going to 4, maybe I try to go to 6. So to do that, I already have 3 oxygens there, so I need to put a 3 there to give me 3 oxygens here, and these 3 oxygens plus these 3 oxygens would give me 6 oxygens. Then I would have to put a 3 in front of CO2 to give me 6 oxygens on the right. It would also give me 3 carbons, right? So 3 carbons, 3 carbons. And the last thing I would have to do is put a 2 out in front of Fe on the right to balance my 2 in front of Fe on the left. So that one was a little bit trickier, but it was just a matter of sort of trial and error to see what would work. And we'll do the other ones in class, and make sure you bring plenty of questions.